Today we're going to take a step back from Java EE in terms of introducing new material, and we're going to think about some of the design principles that we looked at in level 5, think about how we can use the unified software development process with the UML to produce a design for our enterprise applications. Remember that the UML is only a language. It doesn't give us any rules how to approach solving problems, and that's the purpose of the process. So what we're going to do is think about the diagrams from the UML that we would find useful and use the process and those diagrams in parallel to come up with a solution. And then, having got our design, to think about how we could adapt the design, which is generic in nature, to the specific situation of a Java Enterprise Edition application. When we're using the USDP, we're not going to use every single diagram from the UML. We'll start off with the use case model. You're familiar with that, no doubt, and it allows us to describe in a very abstract way the requirements of each user type. The activity diagrams we can use to describe an individual use case. So there will be one activity diagram per use case in the use case model. Then we'll think about the analysis model, which takes us one step closer towards the design. And again, there will be one of those models per use case. And when we've described the analysis models for each of the use cases, then we're ready to start thinking about the class diagram. And there will be one class diagram for the entire system, which will capture all the information that is already in the analysis models and the activity diagrams. For each use case, once we've got the class diagram finished, we can think about the sequence diagrams that will describe how the classes that we've just designed will interact with each other when a particular use case is chosen. We'll need to think as well about the entity relationship diagram, because that will feature strongly in a Java Enterprise Edition application, especially when we're making use of the Java Persistence API. And for the web client, we'll need to think a little bit about page navigation, the views that the user will see, and the way in which the user can get from one view to another. And that will also lead into some discussion about JSF components. Now that's for the assignment. What we're going to look at just now is a case study that you can download from Blackboard. It consists of two files, the Microsoft Visio file, which holds the design elements, and then an implementation. You notice I said an, not the correct implementation. It's only one of several possible implementations. And that's contained in a zip file and contains the entire enterprise application. As we look at this case study just now, watch out for how the UML is used in conjunction with the USDP, and see also how we have taken the elements of the design and implemented those in the application. Let's start with the use case diagram. This is a fairly simple system. We're going to allow students and modules in our system, and this is going to be the interface for the administrator. So we can see on the left the admin actor, and the use cases are add student, delete student, view students, register student on module, add module, view modules, delete module. Those are the things that we'd want to do as an administrator. You'll notice that each of these use cases only has 2 or 3, maybe 4 words. Very brief description of what actions are going to be taken. So this is extremely abstract, very little information. Add student tells us quite a lot of useful information, in as much as we can imagine the kinds of things that are going to take place. But the point of this diagram is really just to show what functions are needed for each of the actors. And beyond that, there's very little detail. The detail comes next, or at least a little bit more detail comes next, when we describe the activity diagrams. For each one of those use cases, we'll have an activity diagram that describes the activities that take place within that use case. For example, add student here on the left. The first thing we will want to do is to find the student. Please note that we are not designing an interface at this point. We are only describing the major tasks that will occur within this use case. We don't design at this stage the interface. We're not looking at screens and we're not looking at interactions in terms of you send me this command and this bit of data and I'll send you something else. All of that kind of interaction, that's to do very much with the solution. At the moment, we're still focusing on the problem domain. So in the problem domain, what is it that the administrator needs to do to add a student? Well, first we need to find that student. If the student does not exist, then we can create the student. We don't want to add a student who already exists. And that selection is described here. After find student, we've got a decision node with two possible outcomes. And the guard statement is essentially the condition. So whichever of those conditions is true, that's the path that we'll follow. And then we come back into a merge node before finishing in this final node. And we'll do that for each of the use cases. Some of them are very straightforward. Some of them are a little more complicated. We've got about 7 or 8 use cases, which means we'll have 7 or 8 activity diagrams, one for each of the use cases. And when we've got that done, we're ready to think about the analysis models. Again, there is one model per use case. We're now taking half a step towards the final solution. We're thinking a little bit about the solution in terms of some abstract classes. That is, classes that are archetypal. Here, for example, we have an admin UI class. That admin UI class in this model is represented only as a single class. But when we come to do the class diagram, where we're really thinking very much about the solution, that analysis class might well end up as several actual classes in the design. So this is only a prototype, an archetype, a stereotype. Now there are 3 types of analysis class in this model. This one here has got the T on the side. That's a boundary class or an interface class. And actors will have access to the system only through a boundary class. The classes that have got a line underneath, these are entity classes. Please do not confuse those with the entity class that we were talking about last week. That's something very different. So this is an analysis entity class. It is unusual for the boundary class to interact directly with an entity class in terms of management. It might well ask some other class to give it a reference to an entity class, and then the boundary class will call get methods to extract data from that entity class. So we'll need this other type of class, the 3rd type of analysis class, which is this one here, sometimes called a control class. I tend to call them a handler class or a manager class, because their responsibility is to manage a collection of entity classes. So if the boundary class wants to find a student, the boundary class will ask the handler class to find that student and return a reference. Or if the boundary class wants to create an entity class or to associate 2 other classes, then it might well be that the boundary class will ask the control class, the handler class, to perform the action on its behalf. Now this is a good principle in software engineering, the separation of responsibilities. So the boundary class is acting as an interface to the user, essentially as a facade, and the boundary class will then delegate all the control of entities to the handler classes. You can see on this diagram that we have certain actions that are taking place. These are messages. So the administrator is passing a message that says register student on modules to the boundary class. And we can see that's the first message that is sent. The next message is from the boundary class to the handler class, and that is a message to say register student on modules. In response to that, the control class here will send a message find module to the module handler, which will return a reference, and to that module that has been given to it, the handler class there will send a message to say register student, and it will then send a message to the student to say add registration. So that will set up a bidirectional relationship, association between student and module. The purpose of this diagram is to identify the kinds of classes that we're going to need to respond to a particular use case. We'll always need a boundary class. We will always need at least one entity class, and we'll need a control class, or at least one control class in each model. And we'll do that for each of the use cases. By the time we've done that, we've got a very good idea of the kinds of classes that we'll need in the class diagram. We'll need some kind of boundary class, an interface class. We'll need some entity classes and some handlers. We also know that for each type of class, what kind of messages it's going to receive. In the class diagram, those messages will turn out to be methods that are provided. We can see, for example, that the admin UI analysis class is receiving register student on modules. So if we go into the class diagram, we can see that there is a class called admin UI that has got a method register student on modules. We'll also see here, because this is now the time to start thinking about the low-level detail of the solution, we can see that it requires a parameter. In fact, this is going to be an array, or at least some collection, of module objects, because we want to register a student on a set of modules. The entity classes are shown here. Now please note that the attributes and the parameters on the whole have been omitted. That's only so that this diagram could stay relatively clean and useful for our discussion today. If I were to do this properly, fully, then every single message would appear in those class diagrams with all the attributes that are necessary in the classes and all the parameters and all the return types and so on. So for your assignment, you'll need to produce this kind of diagram that is fully complete. All of the attributes, all of the methods, all of the parameters, all the return types, and so on. Because the class diagram is all about final solution, we can start to think about our implementation. Until we got to this point, the use case diagram, the activity diagrams, the analysis model could all have been applied to any kind of implementation. It could have been a command line application. It could have been a desktop application. It could have been a web application. But now what we're going to look at is an enterprise application. So we're thinking now of how these classes will begin to feature in our enterprise application. And I've used some stereotypes here to indicate that. For example, the student and module classes are not only the entity classes in the analysis diagram, but we're going to turn those into Java EE entity classes because of the Java Persistence API. In addition, because this is an enterprise application in Java EE, we're saying that the admin UI class and the two handler classes are going to be enterprise Java beans. And we'll decide almost certainly that these will become session beans. Then we've got to decide whether they're going to be stateless or stateful. We will almost certainly decide to make them stateless because, as we discussed a few weeks ago, that's going to be a much more efficient solution in terms of responsiveness and memory management. To recap, we start off with a use case diagram. For each of those use cases, we indicate in the activity diagram the major tasks that are performed when that use case executes. Then for each of those, we consider the kinds of classes that we will make use of and the messages that will pass between them. Those classes and messages then feature in the class diagram as classes and methods. Those classes will have all the attributes, all the methods, all the parameters and return types that they should have. We could then go on, and the case study doesn't show this, but we could then go on to draw sequence diagrams that will illustrate when the command find all students is received. In other words, the method find all students is called in the admin UI class. What happens next? What does that method call and in which class? And so the sequence diagram will show that and will refer back to the kinds of things that were being described in here. So the sequences here will feature in the sequence diagrams that you draw based upon your classes in the class diagram. We also know that given that these classes here are entity classes, that they're going to be related to a database. Therefore, we should describe that database. Using an entity relationship diagram, we can describe the tables that we want. Now, a student should be registered on many modules. And of course, a module will have many students. So we have a many-to-many relationship. We're using a relational database. Therefore, we'll need an intermediate table to represent the many-to-many. So the student module table will have a relationship with student. One student will appear many times in the student module table, and one uni module will appear many times in the student module table. That's quite a simple entity relationship diagram. What is advisable, and especially for your assignment, what is advisable is that you also record the SQL for creating this database, creating the tables with their relationships and their primary keys. Please note the way the primary keys are done here. This is for a Java DB database. So that's how you set up the auto-generated IDs, which is different for Oracle. So if you're using Oracle, you'll need a slightly different set of commands. We also need to show the foreign keys. So I've put in additional constraints here to show those foreign keys. Let me re-emphasize something from the previous lecture. It's very important that you set up these relationships, these foreign keys, correctly, because the entity classes that we're going to generate from the database will implement whatever you describe in terms of these constraints. So you really need to make sure before you generate your persistence unit that the database is complete and has all the correct relationships. I've also got some statements to insert data into the various tables. That will be useful for two things. Number one, when it comes to me marking your assignment, I can see very easily what your database consists of. On a more practical note, when you're developing your solution to the assignment, it is very possible that you will want to recreate your database from time to time. As you're testing, things might go wrong and your database might get corrupted or it might become inconsistent in its data. And you will want to reset the database to some original point. Well, all you have to do is to copy these statements and paste them into a NetBeans window, execute those commands, and your database is immediately reset. So it's a good idea to have those statements either in a separate file or, as I have done here, in the same diagram as the entity relationships. Now that we've got the design, we can think about implementing the application. The source code for the application is available, again, to download from NetBeans. I'm not going to talk you through all of this. I would like you to examine this for yourself and to identify how it all fits together. And then if you've got any questions, then please ask in the tutorials. What I'd like you to think about is the sequence of development. You have the design. What order of implementation will you use? What are you going to develop first? Set up your database first. Then generate the entity classes. That will mean setting up the persistence unit, and you tell the persistent unit, I want to use this database and these tables from that database. That persistence unit will then create those entity classes inside your project. Now you've got the entity classes, the other classes will make use of them. Which other classes? The EJBs, the Enterprise Java Beans, the Session Beans. So the next thing really to develop are the Session Beans. If we work our way back out of this design, we know that the entity classes are going to be modeled, generated from these tables here. We'll do the database first. That will then give us these entity classes. What's using those entity classes? Well, it's these handlers. So that really, in my view, ought to be the next set of classes that you develop. Then the boundary class, because that will use these. The only thing is, if you're not careful, you're going to end up trying to write the entire system, all 10, 12, 50 use cases before you ever try to run the program. And then you'll get a million errors. My recommendation is that you build your database and then you generate your entity classes. Those are almost certainly going to be correct because they have been generated. So long as your database description is correct, then those entity classes will be correct. Then I would recommend you pick on one simple use case. The one on screen isn't simple enough for me because we've got two controllers, two handlers. It would be better to pick something much simpler, such as add module, where we have one boundary class, one handler class, one entity class. And by choosing a simple analysis model like this, then you can, having generated the entity classes, you can write that module handler class, but only providing enough methods for this one use case. Now we can see on this use case, there is one message called create module. And in the class diagram, there is one method called create module out of a total of 3. So what I would do is create this class, but only put in that one method. And then I would create the boundary class with just one method. Make sure that the sequence diagram for this analysis model is implemented in my methods, so that the method add module in admin UI calls the create module method in the module handler that will then create a new module entity and then persist it. A very simple use case that allows me to double check that my entity class is working correctly, my persistence unit is working correctly, and that my understanding of how it all works is correct. So I just implement one use case. Deploy, run, test. Is it fine? If not, I have only got one set of methods to look at. And I just debug until I've got that one use case working correctly. Then I know how the whole system hangs together. Now I can be a little bit more adventurous and implement another use case, and then another use case. So what I'm saying really is, once you've built your database and generated your entity classes, just implement one use case at a time, starting with a simple one, and then bit by bit just add in use case by use case. That's a much safer way of working than trying to write the entire system before you ever run it and test it. Now, it is only a possible order of development that we've just described, but I recommend it as a viable option. You might choose to do it a different way, that's fine, but I reckon that this will give you the least hassle. There's a little bit more information in here than what we've just discussed. Build the database, okay, then create the class library project. Remember from the tutorial work, there are two projects within your enterprise application. There's the entity Java Bean project, the session beans and the entity classes, and there's the web project. And because they share classes, what we create is a third project that contains those common classes. And then we point each of those other projects at the common library project. Because of the common classes, we'll want to build that library project first before we build the other projects. So build the database, create the library project, then create the enterprise application project. First job within that is to create the persistence unit, which will generate the entity classes from the database tables. Then our DTO classes, the data transfer object classes. When we want to pass information that's held in an entity object to some other component within our application, we could pass a reference to that entity class, but that's dangerous. That gives other components control over the database, and we might not want that. In fact, it's a good practice not to do that. What we could do, therefore, is detach the entity object from the database. But that means then we can't reattach it if we want to make any updates. So in my view, it's better to leave that entity object attached to the database and then make a copy of its data, put that copy into a data transfer object and send the data transfer object to other components within the system. When we've got all of that done, then we're ready to build the session beans, which will first be the handlers and then the boundary classes. That boundary class in our example, the admin UI class, essentially is a facade to the rest of the application. And we'll talk a bit about design patterns in another lecture. So next week we'll talk about the assignment. You've had the assignment specification on Blackboard for a while now. I hope you've read it. If not, please read it between now and our next class, and then come along prepared to ask any questions that you're not sure about.